We'll wait 2 to 3 minutes for others to join. We'll start the webinar in 10 minutes. I think most of the people are here, so we can start now. Good evening, everyone. Welcome to today's webinar on PLAXIS. My name is Utkarsha Thakre, and I'm delighted to be your host for this insightful session. Thank you for taking time to join us today. We are confident that today's session will provide you with valuable knowledge and practical insights. Before we dive into the main topic, I would like to introduce you to PIGSO Learning. So it's a based education, research, and training platform. PIGSO Learning specializes in providing engineering simulation training and project assistance, focusing on bridging the gap between theoretical knowledge and practical applications, enabling our clients to solve real world challenges with confidence. Pixo Learning was founded by Mayank Panchal, driven by his passion for accessible and high quality engineering education. He recognizing the need for practical, hands on training that extends beyond theoretical knowledge, and that's the vision is what drives us today. Our services encompass a wide range of areas, including 4.0 softwares. Like we provide software training. This training program is based on industry standard software like Abacus, ANSYS, PLAXIS, SolidWorks, and much more. We offer both live online courses and self-paced learning options also. We provide various services like project assistance. We support personalized project for your engineering research projects from initial concept to final validation. We provide expert guidance on modeling, simulation, and analysis also. We offer customized solution like Pixo Learning offers customized solutions designed to meet the unique needs for organization and research scholars. Now it's my pleasure to introduce our speaker for today, Dr. Dinesh Malviya. He has done PhD in geotechnical engineering from ACSR, an institute of national importance. He is a PLAXIS software expert and a dedicated educator at PIGSO Learning. He has used PLAXIS software extensively for solving complex geotechnical engineering related field and research problems for 7 years. We are fortunate to have him leading today's session. And Dr. Dinesh Malviya, I hand it over to you.
Thank you, Tarsha.
Thank
I
you.
hope
Yes.
I'm audible.
Yes, you are. I'll
Okay.
stop presenting. Yeah, just.
Okay. Thank you very much. So let me share my presentation to you first.
Yes, sure. You can start.
I hope my screen is visible to all.
Yes, it's visible. Mm,
Okay. So thank you very much, Pixel Learning, for giving me an opportunity to present some of my experiences and insights on this software as well as this important topic of file foundation. First of all, I would like to thank the director, Mayank Panchal, to give me the opportunity to present this work. These works are very useful to deliver the technical insights about the software and to discuss about uh, things which are very much needed for the industry. If you find the problems related to geotechnical engineering, these days, people are very much being aware to explore what the things are beneath the ground. Earlier, people are not that much of aware, but due to the increase in the infrastructural development, due to the requirement of the nation to have their infrastructure at the international standards, we have to be construct sometimes more superstructures. Sometimes we need to have more important structures like nuclear power plant, channels, and those things. So in that case, it is very necessary to explore the geotechnical aspect of those region and for those particular problems. So out of those important critical geotechnical engineering related problems, today we will be discussing a few things about the pile foundations, which is being widely used all around the globe. And I have selected the heterogeneous soil conditions to um, construct these kind of foundations, because you'll find that the theoretical knowledge, if you find in books, maybe some other sessions, you'll find people are doing those things in homogeneous media just to have an idea. But I personally feel the soil is not homogeneous anymore. If you dig out at anywhere, any place, you'll find that within a layer of maybe 5 to 10 meters, you will find a lot of heterogeneity in that. Heterogeneity means the soil is of not of same behavior with same stiffness and material property. They will be going to be changed with every meter, or maybe sometimes 5 meter or 10 meter. Actually, the properties get changed with every centimeter, but it's not possible to model these kind of like centimeter and those things. So what we do that in the behavior of the soil, maybe up to, let's say, 1 meter, 2 meter, they are having the similar properties. Let's say they are of cohesive in nature. We'll compile it. If up to some more meters, we will find cohesionless media. So we'll try to model in that way. So considering that kind of approach, I will be modeling a file foundation considering three different layers in soils. And for that problem, I will be the widely used software PLAXIS 2G. So my name is Dinesh, and I will be delivering this topic for this thing. So before moving on, first of all, we'll just try to have some idea about what kind of foundations
Sir,
are
I have
being
a
widely.
question.
Yeah, please.
Sir, can we not use Plexus 3D instead of 2D?
Yes, of course we can use. I think this is Mr. Sharafat Ali.
Yes, sir.
Yeah. Yes, of course we can use, but even the PLAXIS 3D software is more reliable in comparison to PLAXIS 2D. But there comes the cost. Like purchasing the software, PLAXIS 2D is a bit more convenient and, if you can say, economical in comparison to PLAXIS 3D. That's why like people sometimes prefer PLAXIS 2D. But since these softwares give you the preliminary analysis, a preliminary idea about your geotechnical engineering problem, so a more complicated software will give you more complicated results, maybe more reliable or this kind of result. But in any case, if you are able to have that kind of software, of course you should go with PLAXIS 3D.
Okay, sir. Got it. Thank you, sir. Thank you.
Thank you very much. So before moving on, we'll try to discuss what different kind of foundations are being popular in the industry. So basically, we'll categorize the software the foundations into two categories, that is shallow foundations or deep foundations. Shallow foundations are those in which, like if we are considering the two dimension like length and width, so if the length, width, and height, so if the width of the foundation is greater than the depth, then it will be the shallow foundation. But if the depth of the foundation is greater than the width of the foundation, then it will be considered in the category of deep foundation. So shallow foundations are typically known widely as rock foundations, and the bearing capacity of these kind of foundations is being, let me use the highlighter. Yeah. So this is your rock foundation over which you can see the huge building is being constructed. So the bearing capacity of these foundations comes from only the end bearing and the shear resistance, whatever these things are applied here. But in the cases of deep foundation, you'll find that end bearing is there, but along with the end bearing, you'll find the skin resistance or skin frictions comes into picture to mobilize the load coming from the superstructure like this. So these are the basic idea. And there is one more type of foundation which is being very popular due to its load sharing and behavior. It's a piled rock foundation, in which what is happening in piled rock foundation, we utilize the bearing capacity of this pile as well. And at the same time, we are utilizing the bearing capacity of this rock coming from the end bearing. So if you see that in pile, if only the case of pile foundation, we are just utilizing only the capacity, the behavior of this pile and ignoring the capacity of this rock. The rock is only provided considering when we are considering it as a pile foundation, the rock foundation is only provided to give the strata, to give the surface just to transfer the load to the pile. But we are not considering the bearing capacity of this thing. However, when we are going with the pile rock foundation, we are considering the bearing behavior of both these two foundations. So in this case, what happens, there are several interactions which are coming into picture, which makes this foundation to be a unique foundation, such as the raft and the pile interact, raft pile interaction, pile interaction, and pile and raft interaction. These different type of interactions comes into picture to mobilize the load coming from the superstructure structure. They are also useful in resisting the bending moment induced in the foundations. So what we can summarize about the foundation, they use the improve the bearing capacity, reduces the overall and differential settlement, perform effective against the moment load coming from the wind, earthquake, and tidal these things. For minimizing the differential settlement, this is one of the most important parameter which we should take care when the soil is of maybe sometimes cohesive or this kind of loose or maybe liquefaction area. Differential settlement, what will happen, the one portion of that particular foundation is going to settle, whereas keeping the other one at the same place. What this may induce a large amount of crack leading to economical and losses of life. It is happened at many places. So to encounter these kind of problems, the foundations are of effectively rigid, and the rigidity and flexibility of the foundations are a different topic to be covered. Basically, they are governed by one of the factor known as soil rock stiffness factor, in which the Poisson's ratio, the Young's modulus, and those things are coming to picture. But we are not going to discuss the soil rock stiffness and those things. So basically, they are useful in differentiating the flexible and rigid foundations. So these are some of the empirical relationships which is being developed to calculate the load carrying capacity as well as the interactions between these special type of foundations. You can use these empirical relationships available here from the literature to quantify the load sharing between the pile and the these are some of the superstructures which are built over these kind of foundations, pile foundation, and especially pile rock foundation. We all know the iconic foundation, iconic structure, Burj Khalifa. It is I think presently it is one of the, maybe the tallest existing building in the world. There are 194 piles have been used. Their length varies from the 194 piles of 47.45 meter has been used, whereas 750 piles have been used in the range of 30 to 35 meters. This rock is of Y shape, and whereas the thickness of this rock varies, at least it is ranging from 0.65 meter to 3.7 meters. This is one of the old and widely cited structure Messenger in Germany. It is built over the 64 piles having the length varying in the range of 26.9 to 34.9 meters, whereas the rock dimension is 58.8 meter by 58 meter. This is Ampolage, a building in Japan, which is built over 43 piles having length of 20 meter, 86 piles of 20 meter, whereas 19 piles of 25 meter and 12 piles of 25 meters at the same time. The dimension of the rock is 56.7 meter by 156.3 meter. And the other one is World Financial Center, it's in Shanghai, and the number of piles, 225 piles are built with length of 60.7 meter, whereas 760 piles are of 41.7 meter. The rock dimension is 70 by 70 meter. So these are the massive structures which are built over the pile supported by the rock. If we talk about the foundation, like there are several kind of loading which are being imposed on the foundations. In a very general case, the foundations are being loaded vertically. These vertical loads comes from the self weight of the structure, whereas some structures are laterally loaded. And this lateral loading, you can see in most of the time in offshore, onshore, this which are being some such as uh, induced with the lateral loading. But there are certain cases in which the foundations are being loaded during the combined loading. Combined loading means the vertical load coming from the superstructure, whereas the lateral load coming from the maybe tidal waves or something at the same time. So when these two loads are working simultaneously on the foundation, we call it to be the foundations are combinedly loaded. The foundations are also induced to bending moment loading. The moment loading comes from, like, if your superstructure is built here, maybe some wind load coming in this, which induces the bending moment here. So so these foundations are also subjected to bending moment sometimes. In most of the cases, like in the case history, you'll find that these piles are not of uniform length. You can see some piles are 30 meters, some are 47.5 meters, some are 20 meter, 25 meter. That means in actual field conditions, you're not going to have the foundations with uniform length. We do this kind of analysis just for our simplicity or just to have an idea about that thing. But in most of the time, you'll find, depending upon the requirement of the project, the piles are of non-uniform length. Sometimes you'll find the longer piles in the middle region, and sometimes you'll find the shorter piles in the middle region. Both these cases depend upon the requirement of the project and site at the same time. If you are having your foundation is subjected to this kind of more loading, more column loading coming in the between region, then you need to provide this longer piles here. But sometimes if the loads coming from the columns are higher at these corners, then you need to provide longer piles at the corner. So these are the case of foundation being subjected to different types of loading. Uh, Today we will be discussing about the pile foundations. So I will just give you some idea about what different kinds of pile foundations are being in nature. Uh, First of all, the end-bearing pile. The end-bearing piles are those piles in which the tip of the pile is being supported on some of the hard strata, maybe has been lying on the rock or something. So in that case, most of the bearing capacity is being uh, developed due to the end bearing. Uh, the friction pile are those pile in which the load being mobilized mostly from the skin resistance. Mostly you'll find this type of piles being effective in cohesive soils. Some are compaction piles, which are being driven into the pile using the compaction. Tension piles are mostly used in the transmission line towers. Anchor piles are those piles in which the tip region is of similar with the anchor, and they are just socketed to ensure some uplift forces. And sheet piles are a kind category of pile. Mostly they are provided to uh, sometimes in the region of excavation, drawdown, or those things, just to provide like poker dam and those things. So these are some of the widely used piles. Depending upon the type of material, like it may be steel pile, concrete pile, timber pile, depending upon the driven, like it's a whether it's a driven pile methodology of the construction, it's a driven pile, or maybe it is a board pile, casting sheet pile. There are several other classifications we can discuss, but for your knowledge and just to have an idea about that foundation, I just covered this only. So What are the factors which affect the selection of file? You need to have an idea about the nature and type of the soil, the type of soil and associated properties, the groundwater table, the length and number of files, the case study of adjacent building, whether it is an old building, ancient building, or new building, you have to consider that aspect also. Facility of file driving, whether you can drive the file here. If it is not possible or economical, you need to go with the board file at that time. The erosion of soil near the structure is it very heavy of that kind of that you need to like have an idea about these different type of cases before selecting your files. So today we will try to discuss and model the board files. This is a construction type and which involves the drilling hole. First of all, we need to drill the holes in the ground, and then that drill hole will be filled with the concrete to create maybe most of the time cylindrical bodies are there, but if you can excavate that region into rectangular and those things, that is also possible. But most of the time, the boring and the drilling is being due to the auger, which is circular in nature. That's why we need to most all the time we have the circular drill. So we'll pour our reinforcement cage in that, and after that we'll apply the concrete. So this way we used to create the board coils. It is useful because it is used widely because it does not create any additional vibration, and consequently it does not result in any development of pressure bulb for like um, for collapse on that. So like overlap of the stress zone is not being seen in this board pile case, whereas when the driven pile is there, you'll find that our stress zone overlapping due to the vibration induced happens. So mostly these board piles are useful for the heavy foundation to secure the deep excavation. You can like drill as much as possible upon depending upon the requirement. It is useful for stabilizing and retaining slope, tunneling, road or bridge construction, flood protection, many ways. Like it has a wide range of applications. So with this small background of the tile foundation and other foundation, because I have split the session into two parts. First one is to give an idea about the foundation to the audience, and after that, I will try to have a small session for hands-on modeling using the PLAXIS software, preferably PLAXIS 2D software. So first of all, let me open the interface. So meantime, if you have any discussion before starting the software, we can have that. If you have any queries or question in between before starting the software interface, we can have a small discussion. Uh, yes, please. Somebody has raised hand. Yes, Mr. Thoram.
Sir, I'm beginner, so is there any problem while using PLAXIS 2D?
For a beginner,
Yes, sir.
no, I think there is no problem. Plaxis software is one of the user-friendly software until and unless if you have some uh, preliminary guidance, because you have to know the interface. You have to have idea about like what kind of uh, stages involved in that. So with that idea, I think you can, and yes, you need to have a like a background of like civil engineering, preferably geotechnical engineering. So I don't find that it is that much difficult to learn the software and use it.
Okay. Thank you, sir.
Yeah, you are you from like civil engineering background or some else?
Sir, currently I am pursuing my master on geotechnical engineering.
So that's great. It's a very favorable conditions for you.
Yes, sir.
Yeah. What
I'm
kind
little
of
bit of late on Plexus 2D and 3D.
yes, yes, you can because we are having multiple batches for PLAXIS 2D and 3D combined with lot of geotechnical engineering related different problems. You can join that.
Okay, sir. Thank you.
Yeah. That's all. So I think our software interface has been opened. So this is how the software interface looks when you click on the software. So since we are starting a new project, you need to click on Start New Project. So this type of window pops up. And first of all, it will ask you the title, what kind of title. So just write file modeling. You can write anything as per the requirement. You can write your company name here, write company one. And you can put here some of comments just for your understanding. Like maybe we are modeling bold file. And here you need to define the type, contour, and units of your problem, project property. So there are several different things. I will not go in very much deep because due to time constraint and the variety of audience available, maybe if I go more mathematical and technical aspect, it will not be useful sometimes. But I'll try to have a balance between all kind of audience. So I'll try to deliver those things in that way. So first of all, we'll try to model our problem using the plane strain or axis symmetry. So if axis symmetry means if let's say the dimensions of the problem are symmetric, then it's no need to model the whole dimension. You can restrict it to the half, maybe quarter sometimes, just to reduce your computational efficiency and just to reduce the time involved in calculation. Otherwise, you can use plane strain problem. Mostly it is used for slope stability or the if you are modeling a full scale uh, uh, what we call the foundation of the problem. So we are considering the plane strain model, considering the 6-noded or 50-noded elements. So what is happening? The problem will be discretized into 6 or 50-noded elements. So if we are considering 6-noded, obviously the elements will be less. That will lead you to more leading to less time consumed. Whereas if we are considering the 15-noded elements, it will increase the number of nodes and that thing, which will increase the time involved. So after that, we need to define the contour of the soil domain discretile. While considering the contour, you need to have an idea about the boundary conditions involved. So most of the time in layman, you will see that if the raft or shallow foundation is there, the influence of that particular foundation is up to the 5 times of its width. Influence means the involved stress zone, involved the settlement contours and those things. So when you are doing any type of finite element modeling, you need to define your contours very wisely. Let me define something like 40 meter of horizontal length, and from here you can have some 20 meters of depth, because the depth of the, if you are considering the pile foundation, the influence zone is up to at least 1.5 to 2 times. If you're considering the 10 meter of pile length, you should minimum define the vertical or the depth boundary up to 20 meters. That is 2 times of that length. These are the units which we need to take care if we are using the NKS system like meter, kilojoule system, or otherwise you can change it into PTI depending upon the type of units you are using at your places, and change it from here. The constants are like this, like the unit rate of the water and these things are almost constant. You can change depending if the problem is special or it makes any other type of property. So with this, we'll just click OK. You have saved. First, you need to save this so that whatever operations you are doing will be saved there. Okay. The very first step involved is to define the geometry of the model. That is the length of the foundation, the width of the foundation. You need to define your material properties. You need to define your boundary conditions. You need to define your borehole. So these things you need to create first. After that, so let me do that first. Then we'll go to the next step. So for that, you need to go to soil. You need to define. You have to click on the modify soil layers like this. This window will come, and now you need to define the boreholes, because when you are considering any geotechnical engineering related problem, you need to rely on the borehole data. So I have some material properties for you. Go to the material. Just provide here the top layer. Let me call it as maybe 1 just for our understanding. And the properties, like I will just explain for one because that will be repetitive. There are different type of soil models are available in the software, ranging from linear elastic, Mohr, Coulomb, Hook and Brown, jointed rock, hardening soil, small strain model, modified template, NGI, ADP, soft soil quick, Regugio-Orta, insert Regugio-Orta with SIG, UD CAMS, concrete and user defined. So these different type of models are soil models are used. Every model is unique in their nature and it is unique in their application. Let's say if you're interested in modeling the rock or something related that, or hard strata, then you need to either go with the hook and rock or jointed rock. If you are interested to model the maybe clay, or if you are interested in capturing the differential settlement and those things, then you should go with the hardening soil or hardening soil small strain model. If you're exclusively modeling the soft soil, then you can use this soft soil or soft soil model. Or if you're interested in modeling in general soil condition, you can use a widely acclaimed and used molecular model. So you can choose any one out of this. So for now, I will be considering the hardening soil model from here. Range conditions. The unit weight is 20 in unsaturated, and we will consider a bit higher for saturated condition. Now we need to define the mechanical properties. So let's say the thickness is 40,000. I will just touch all the aspects quickly due to time constraint. See, You need to define the E50, these E audiometric and E unload reload will be automatically changed. So basically, as per the empirical or analytical formulation, the E50 is equal to EOED. That means if we are selecting 40,000 here, automatically the 40,000 will be here. Whereas the E unloading or reloading is 3 times of the E50. So it will be 120. That's see automatically it is being included. All these things I will discuss like how these things are being done, how these empirical relationships are there in my ongoing courses through the PIGSO learning. So I have explained all those things there. And you can define the shear strength parameter. So the cohesive value we are taking this much and the angle of internal friction is 30. Okay, so you can change the groundwater you want to mention, the thermal properties, interface, distance you can mention here. Once you define, just click OK. We have modified the first layer. Now we go to the to this layer using the hook and crown model. I think do you have any questions? Okay, the question is how do you calculate E value? Is it based on vowels or do you compute through some other relation or better accuracy? The best and widely used reference is K.E. Bauer's Advanced Foundation Design. But if you are able to have advanced geotechnical engineering laboratory, you can compute all the results from the using this triaxial or cyclic triaxial empirical relationship. There also you can calculate, but mostly it is used from the Bowers. Is it okay, Mr. Arun?
So good evening. Suhas Golam here.
Yeah, Mr.
In the first layer, below that E value, the mu or the Poisson's ratio
Yeah.
was indicated as 0.2. Can that Poisson's ratio be that low for a soil?
Yes, it could be sometimes because it is a stiff soil layer. If you increase the stiffness, see, it is having the stiffness of 40,000. That's why we have taken 0.2.
0.2 is close to like that of a rock.
Kind of, yeah. It should be like 0.2, 0.22 or 2.3 you can consider. Actually, if you increase the stiffness, it will be on the lower side. You are correct. For rocks, the stiffness values are quite higher, sometimes 80,000 or something. So in that case, you can go a bit lower, also 0.18 to 0.15. So these values are just for reference. Like if you are modeling, actually, you need to be very careful again.
Okay.
Sorry to interrupt you. We
Yeah.
do all the Q&A in at the last at last only. Okay.
Okay. Thank
At the
you.
end of the webinar only, we can do all the Q&A. Yes.
Okay. Okay. So for moving there, on the ground, we will just fill the properties of the soil. So these are some of the well related to, like, if you are considering the hook and round, basically you can see it is a kind of rock strata, and Poisson's ratio are a bit lower. We need to define the uniaxial compressive strength for that. So once these properties are defined, you can change the interface property, which is this. Now, okay, and we'll define our third layer. Bottom layer. So since it is also the steeper layer, that's why we are considering to design it using the hook and crown model. The stiffness of this layer is comparatively higher in comparison to the middle layer. And the uniaxial compressive strength is 50,000 kPa or kilonewton per meter square. So these are our layering system. We'll try to add 3 different layers. For borehole 1, are considering and from here you can assign the material properties like this. Now we'll add the other borehole. We'll call it borehole 2. So this is just to give you an idea about the layering system, what we use to have, how we can define our layering system. We will add another borehole. That is borehole 3. So we can change this. In this way, like you can have multiple boreholes in your problem. So you can just see like this layer of this much of thickness. These are three different layers and having three different thickness at different locations. Basically, we have considered the horizontal boundary from -30 to 10, that is of 40 meters of length. In that 40 meters of length, we have considered one borehole somewhere here, or other the borehole here, other borehole here. You can have multiple boreholes and define the properties. So the interface looks like this. This is our soil control, and now we need to define our foundation. So first of all, we'll define the properties of that pipe. Let me right here, foundation, and check the associated properties. You can consider the elastic non-porous behavior. We need to define our rock foundation over the pipe, which will be defined using the plate element. So once we have defined all the material properties, we'll just model in the structure mode. You can go to, there are several options, like if you have same dimension, you can use the area option. I will use it and let me show you. You can use the create line to create the plate element, geogrid, table, discontinuity, many things you can do that. You have options to create your soil polygon. If you can use this option tunnel for tunnel designing. You can define your loads, maybe it is a point load or line load. You can use different type of displacement. Basically, we do different type of analysis. One is load-based approach, and the other one is displacement-based approach. We do apply some displacement and observe the consecutive load. You can use this, and you can apply some of the connections using the friction anchor, the geogrid, cradle, and all. Also, you can define several hydraulic conditions. You can thermal flow boundary. So there are several options which you can use. So currently we are interested in modeling the plate. So since it is a 40 meter of boundary, consider it like this, and you can assign the network property. Now you can model your file. So we'll use PXY polygon. So this is one file, and we'll assign the file material to the file foundation. If you have multiple files, let me change the color also. Just have an idea. So this is our file foundation. If you have another file here, you can just create array. So just select this file. Okay. And we need to apply some vertical load on this. So you can create line load, just click on the previous sheet, and you can define the magnitude of this here. So since I will try to simulate some multiple loadings which we need to do on the foundation, so you'll model all those things here. So as of now, you can see your file foundation supported on Draft is being constructed in the heterogeneous file media. Next step is to create, like these are the modeling part. First one has been done. Now we'll generate a finite element mesh. So we'll go to the mesh portion. Generate mesh. PLAXIS allow you to do different type of mesh options for the element distribution. I'm considering the coarseness just to have complete low frame of time. However, if you are considering very fine endorsement, the number of elements and nodes will be quite higher, but at the same time, they are more reliable and provide you more accurate results. And it needs a good amount of time to apply. C. The discretization has been completed and the 530 elements has been generated with the 4333. That is more than 4,000 nodes have been completed. So you can see the generated mesh using the view mesh option. So the discretized media looks like this, which has been distributed in different types of nodes and elements. After defining these things, you need to have the space construction. So here we will define like how we need to apply the loads and those things. So initially, before any type of construction, the ground is in its sticky stresses condition. So here we are not going to activate any of our structure. From here, we'll add one phase. We'll write it for modeling foundations. So in this, see, when we are activating, so we need to apply the properties of So in this, we have activated our file foundations, and we need to activate our plate also. So this is activated, foundations has been activated. In the next step, we apply load. So just here I will apply two loads. Let me write load one of some 20 kilonewton. I will apply to two of 40. It's okay. But when we are here, we need to activate our line loads. We need to define the magnitude. It's 20 kilonewton in downward directions. It's minus 20. The other one is. So in this way, you have defined all the things. Just have a recap. In the first step, only soil layers are there, so nothing is being activated. Foundations. In the next step, that means the construction of foundation has been done. Now we have activated our loads like this. Before that, we'll save this. And from here, we just run this problem. The PLAXIS automatically will try to develop some of the information you can see. And these are the displacement and rate acceleration. These multipliers will be used for collecting the data from the outer region. And here you can define the iterations involved to solve this problem. Also, the maximum steps involved and tolerance level which we are considering. These all things can be fixed. So we have considered the tolerance of 0.01. That is 1%. You can keep it as low as possible and minimize the error. And this you can see the elementary computation nowadays will happen. Once these things are successfully calculated, these green ticks will be there. If it is not a successful calculation, maybe due to some technical errors or something like that, then it will be red color and it will show you the message. So in our case, everything has been defined very well. That's why we are not having any kind of difficulty. All these things are green in nature. Once your model has been analyzed up to this level, the next thing you need to have the results. So just click on the view calculation results. It will take you to another interface of PLAXIS advanced output. So from here, you can see different type of information controls. In initial phase, when nothing is there, you will find all the soil layers are intact as we have modeled. If you're interested in vertical information, just do that. Once we install your foundations, due to the self weight of the foundation itself, you can see the contours. So these are showing the settlement, and you can correlate the magnitude of the settlement due to the self weight of the foundation itself from here. But once we apply an external load, you can see the deformation is being increasing. Like when you have 40 kilonewton, you can see the maximum region is 0.38 in the 10 to the minus 3 meter. The settlement corresponding to 40 kilonewton. When you're lowering the load, see it is going to be less 0.28. It is quite obvious when you increase the load, you'll find the maximum settlement. One interesting thing you can notice that when you are loading, the maximum settlement is in the middle region. It's a red contour. See? But as you go to the away from this, you'll find the settlement getting less. So to cater this kind of problem, we need to provide unequal file length, and in that longer files in the middle region. You need to take care of those things while you're designing a problem actually in the field. Also, PLAXIS gives you an option to see the using this arrow option. can see everything are there in the region. You can see using these colorful, wonderful color controls. If you're interested in the file foundations, just click the tab. Okay. What will happen if you're interested in calculating the forces reviewed in this foundation? See, these are some of the contours being available. Just go through forces. If you're interested in axial forces, just click on that. And these are the axial force distribution along these ties. If you're interested in calculating the shear forces, just click on that and you'll see the pictorial representation here. If you're interested in calculating the bending moment induced in the file, you just click here and you will see some of the calculations here. So in this way, you can, like using the PLAXIS 2D software, you can easily calculate the deformation. You can easily calculate the forces induced in your file. Also, you can click on the rock foundations and see the force distribution, maybe axial forces distribution like this, shear forces, the bending moment, all those things you can. So these are basically the important design parameters which need to be evaluated before going to the foundations. So due to the time constraint, I have not included many things available in the PLAXIS software. Okay, this is just an idea. Also, this allows you most of the time to do the numerical analysis. You need to present your the whatever analysis you have done to your superior or maybe for your record keeping. What you can do, you can just go to this option print and just click on the print. It will go to your printer. But if you want to just save it, you just go to this, copy it, and open your Microsoft Paint or somewhere, whatever, just paste it here. You can see this kind of record keeping in your presentation you can do. Whatever you have, like file marking your project name and company, whatever you are referring to, which date you have generated, these all things come in this way. So these are for output file kind of generations. So you can have that also. So these are options. And one more thing, like whatever, let's say the deformation you are seeing like this, you can have it in detail by clicking on the table option. You'll find that, see, we have soil layers ranging from up to 20 meters. So the difference with every elevation, we can, like this is y-axis. So you can see it is increasing in y directions. So for more detail, you can have it. So with this, I think the time is there. So with this background, you can have use this PLAXIS 2D software specifically to solve many complex geotechnical related problems. So this is from my side. If you want to have anything, you can discuss before closing. Okay, I'm finished, Rahman. And we have some questions that we go through it one by one. I think Utkarsha, shall I read the questions on my own?
Yes, yes, sure.
Okay, I think we have answered the case. Let me take some few more new questions. Mr. Nisar was my lecturer. Thank you very much, Mr. Nisar. May I know the role of modeling for file boundary condition, etc. What will be the soil depth with etc. Yeah, of course. Since numerical modeling, the boundary conditions are one of the prime concern which should be taken by the designer. As in the very beginning of this session, I have already told, like for in general, for rock foundation, we need to have uh, the boundary conditions should be 5 times of the width of the foundation, the lateral direction, whereas in the vertical direction, you should at least take 1.5 to 2 times. That's why we have for a 10-meter of pile length, we have model 20-meter of depth of ice. So see, this is 10-meter of pile, but we have model up to 20. We have considered some limited boundary condition in lateral direction also. However, it should be 5 times. So yes, there are the rules which you should go through the literature that will help you to take the boundary conditions for different problems. Mr. Arun, what are the advantages that you get when modeling file as a soil method instead of a plate? Okay. Two, it is possible to find SBC, so bearing capacity requirement for the rock loading in PLAXIS with some sizing here. Okay, so I'll answer the first question first. Yes, you can model using that. Embedded beam option is there, or other you can model like that. But if you're modeling it here using the linear elastic non-porous nature, then you will be getting the more soil structure interactions with that. It will be useful for you to have the interface properties will be utilized for that. But yes, you can use it using the embedded beam option also play. The second is it possible to find? Yes, set bearing capacity could be find. Let's say I have applied some load here. We have applied two different loads. So you can calculate or derive the load settlement curve. Let's say for 20 kilonewton, you are having this much of settlement. Okay, so plot it for the next load for 40 kilonewton. You are having some other thing. So in that way, you can plot your load settlement curve for different loading. From there, the conventional rule for finding out that thing is you can have the double tangent. You can use the double tangent rule for calculating the safe loading capacity of the foundations. That will be useful. And can we model file area? Yes, you can model it. Not a problem. How we measure the pile capacity value from this model? So that's what I'm saying. Like you should apply different loading to have the different set corresponding settlement. You need to plot all the load versus settlement problem up to the point that the curve is getting flat, because once in initial stage when it is in the last region, the settlement will increase correspondingly with the load, but you will find that the curve will start bending into the non-linear nature, and once after some time you'll find it flat. So for that, from there you can have the double tangent uh, elevation and calculate that thing. Yes, Mr. Arun Sri has. I hope I have answered.
Yeah, yeah. Good evening, sir. It's Arun here. So, am I audible to you?
Yes, yes, please.
Yeah. Thank you for the wonderful presentation, sir. Uh,
Thank you.
so, I have to start from the scratch to learn Flaxis 3D because there's so many data we need to feed from the laboratory test results we are having in hand. And in the Plaxis studio as well, there are so many terms that are coming up, and we have to have the information of what those terms actually means and to on what scale do they vary from the lowest to the highest. And upon feeding all the data and generating the result and understanding the importance of that result, so will it, I find it very complicated at this moment. But how easy will it be, sir? How long will it take? anyone who is starting from the scratch to become proficient in this?
Yeah, I find that for a beginner, the PLAXIS software is one of the best software for a geotechnical perspective. For that, first of all, let me tell you, you need to have at least a background of that. Like mostly we used to solve geotechnical engine related problems with the PLAXIS software. So you need to have an idea about the geotechnical engine related terms such as shear strength, the bearing capacity, those terms, technical terms.
Yeah,
And
at the
then,
moment, I'm pursuing the PhD in masters. So,
what?
yeah, I'm pursuing the masters in geotechnical engineering so at the moment.
That's great. That's make you like what should I say? You are the right person for this software
Yeah.
because you have good geotechnical engineering background, and then at the same time you just need to have some idea of the finite element formulation on which the software is working. And after that, you need to have an idea about all the steps involved and how to model the material modeling, and the good knowledge of boundary conditions, the finite element generation. And after that, you just need to have like after a few practices, you can like how to take out the data, desired data. Sometimes if you're referring to the deformation, maybe the forces induced in the pile or rock, so that could be done. So in our ongoing courses on PLAXIS 2D and PLAXIS 3D, we have designed the course in that way. First of all, in some initial lecture, we need to give you an idea about the finite element formulation, some mathematical things, so that a new user feels comfortable with the software. And after that, we have defined those things in a way so that to solve different type of geotechnical related problems ranging from the slope stability to foundation tunnels and those things, embankment excavation. So we have designed our course curriculum in the PIGSO learning in that way. You can refer it. It takes less time to get into it because we have designed uh, in that way. Yeah,
Thank you, sir.
thank you. I think so. Exact box. Calculus, this I have answered. Modeling soil polygon, we give width as yeah. So equivalent width you have to give because we are not modeling a circular. In PLAXIS 3D, you can model circular piles, the tapered piles, the rectangular piles, but in PLAXIS 2D, we have that much option. So you need to do that. You have to create a soil polygon width in similar to the pile diameter. Yeah.
Thank you, Dr. Dinesh Malviya, for the excellent and informative presentation. I hope everyone found the session valuable. And before we wrap up, I would like to remind you on few things. Like we have an upcoming batch for Plaxis 3D online training program and for Plaxis 2D also. For 2D, we are going to start a new batch from 22nd March, and that will be only on Saturday and Sunday. I'm gonna mention all the details in the chat box. And for Plaxis, we have an upcoming batch from 3rd April. Another thing, for the more information and upcoming courses and training program, you can visit our website that I have mentioned in the chat box or in chat box also. We offer training in a wide range of software and engineering topics. And if you have a specific project and you need help with, so please don't hesitate to reach out to us. We offer personalized project assistance to help you to achieve your goals also. And at last, I'm mentioning two links, feedback links. So please take a moment to complete the short survey. And we value your feedback, and your input will help us improve our future events also. So thank you all for attending, and we hope you found this webinar beneficial. We'll be sending out a recording of a session to all the attendees shortly. And have
Yeah,
a
Miss
great
Arun,
day. We
I
look
have a small
forward to
doubt.
connecting with you at our next event. Thank you. Please, I have pinged that link. Please go through that, and please take a moment to complete that. And we value your feedback also. Yeah, please rate us. You can all check in chat box. I have added the links for feedback. Yes, Arun, do you have any question? Arun, you there?
Yeah, it's Arun. Am I audible to you, Miss?
Yes, now it's audible. Yes, tell
Yeah,
me.
I had this doubt that Sir mentioned that having a knowledge of filing element method is essential to learn this software. So, am I getting also trained up for this course as well alongside the PLAXIS 2D when I
Yes,
take the
you can
course?
enroll in Plaxis 2D batch. We have an upcoming batch from 22nd March.
Yeah.
Yes, I'm sharing you the details also in chat
Okay.
box. And
Got it.
whatever
Thank
you
you.
have, you can ping me on, or you can ping us on WhatsApp, or you can email us on our website also. Or do
Okay.
check our website link.
Huh.
You will find
Huh.
all the upcoming training programs and everything on that website. You can enroll
Okay.
from there also.
Thanks. Fine.
Okay. Yes.
Thank
Sure.
you.
Sure. Yes.